Assalamu alaikum. Hi everyone. In these tutorials, I will show you how to perform single objective optimization of building form, window to wall ratio, and shading devices for thermal energy performance. I will also show you how to create multi-objective optimization of building form, window to wall ratio, and shading devices for thermal energy performance and daylighting. As you can see here, I'm showing you one of my scripts that was performed for research before. Here you can see the building model, which actually is very complicated, but I will not do this complicated model of in these tutorials so as to simplify the issue for you. And here you can see I will also show you how to perform Honeybee individual zoning instead of doing just one zone or generic zone for all the spaces. You will be able to assign each space a specific thermal zone. And here the TT toolbox is used to record the values of the dynamic parameters, such as the window to wall ratio and the shading devices and so on, in addition to the corresponding value of the specific objective, for example, thermal load or the daylight. And here's the window, but in this case, the windows were not manipulated, but I will show you how to manipulate the window to wall ratio. And also here, the shading devices were not manipulated, but I will show you how to manipulate the shading devices. And here, the EPW file used for the specific city. And of course, how to visualize the model in the beginning and how to visualize it at the end when you have data for the thermal load and you have data for daylighting and so on. And here I will also show you how to assign specific materials for a specific climate. And here, as you can see, here's Octopus, and it's connected to the values of the dynamic parameters that were performed. These dynamic parameters were mainly for the building form. And there are too many because, as I told you, it was too complicated case study. Here, the objective functions are, as you can see here, are connected to Octopus. We have these values. And so let's start. So as I told you, this was an old project that I did before for research. So now, as you can see here, we need you need to make sure that you're using the meters in the Rhino. And in order to change this, you have right click, then unit settings, and you can choose meters from here. So, okay. And as I told you also, this was a very complicated model that we're not going to use for sure, but I need first to turn off the simulation so that we do not have the model simulated during the tutorials. I will turn off the simulation for the daylighting too. And now I will remove the model from Grasshopper. All these components represent the model, the building model. I have deleted them. And then I will start doing a simple form. So here I will choose a box. And as you can see here, we have the meters, and each box is 1 meter by 1 meter. So I will assume that we have, I will first turn off the grid snap, and then I will assume that we have a core, which is, let's say, 5 by 5 with a height 3 meters and surrounded by make sure that you're drawing the boxes or the zones of your building attached to each others without any spaces, because this actually will cause the model or the simulation engine not to run well, or actually it will not run in a good way. So I will start to make four rooms that surround the core. Each room is 5 by 10 meters. And of course, they have the same height. So now I will select all these zones and copy them in order to create second or a first floor. An important issue is how do you render or how do you present your brick? Sometimes you might get a major review in a journal, for example, due to the clarity of your figures. So here you can use the option display options. And as you can see here, we are in the shaded choice. So here I will use a solid color for the background. I will choose white. So here the model appears in a better way. And also I can change, I change this after finishing, after I can change this grid, I will choose not to have a grid so that I will present my model in a clearer way. And as you can see here, we have the north direction. So I will start to model the building form inside the Grasshopper. So here I will choose VREP. And then I will connect, for example, this VREP. Again, another VREP. I'm choosing separate VREPs because I want to manipulate the boxes separately. I don't want to treat them all equally. So here I will choose set one VREP again. Now you can select these boxes inside Rhino and choose to hide them. But you can see the other boxes in the ground floor. And here also you can align your components. Again, here I will start to assign so now we have all the components of the model, and here I will choose to hide ground floor. And now let's assume we want to manipulate the height of the boxes in the first floor. So I will choose or bring scale new from in the canvas. And here I will hook up one of the boxes to the geometry. And in the base plan, I will hook up a point and put this point in the corner of the box. In order to put it in the order of the box, I will need to hide swap, which brings back the hidden geometries inside the Rhino, Grasshopper. And here I will put a point here in the corner and set one point. Again, I will hide this one. And here you have the X, Y, and Z. We will not manipulate the Y and X. We just want to manipulate the Z. Let's assume we choose 2, which will be double the height of the box. As you can see here, it's doubled, but let's say that 2 is too much, and 3 also, because 3 will make the box this space 9 meters in height. So I will edit this, and let's say x times 0.5, and I will start by 2 so that we have 1 and maybe 1.5. So now it's fixed. And as you can see, the box moves in its direction. Let's assume we don't have this point. You can see that the box it changed its position. So that's why we add the point. So let's do this for the rest of the boxes in this floor, in the first floors. Maybe in order not to increase the calculation time of our experiment, I might do it for just maybe 3 boxes. So now we have this option of increasing the height of some of the zones in the first floor. And these are called the values for the dynamic parameter, which is the roof of the building. So let's assume that these are the form dynamic parameter. These are the values for this form dynamic parameter, which is the roof. And now let's take this all as and group it as the model. Here we have the building model, and now we need to hook it up here in the building masses, which is called intersect masses. So again, I will hide this from Rhino so that I can see what's happening here. I will also turn off preview off all these components. I will start collect them in just one brep. So here I will not take this one, but rather I will take this because this is the last component for this box. So it's now available in our Rhino. Click on Shift so that you could hook up more than one component. So we will check to make sure we have 10 zones here. So we have 11. So there is a problem where in this component we have hooked up something more than one time. Or maybe we have assigned 2 BREPs for just one box. And this is a very important point. You need to check step by step that you're modeling your building in a good way, because you cannot fix these problems later on. So here I will check. I will start by maybe preview of this and start preview on to check where is the problem with my model. So here we find that this one was assigned 2 times. So I'm going to delete it. So we have now 10 zones. In this case, as you can see here, the model changed during the optimization, which means that an internal wall is going to be divided into 2 parts, one external wall and one internal wall. So I will preview off these components and preview this on and show you that this component, which is called intersect masses, it makes sure that your model is read in a good way. So we have the external walls, the internal walls. It divided one surface into 2 parts, as here you can see here. We have one wall, which is part of it is an internal wall, and the other part is an external wall. And now here there's a problem. In order to know what problem do you have, you need to click on this one. So here the number of items in the connected zone programs list does not match the number of connected zone masses. And that's true because, as I told you, I had in my previous project, it was a very complicated one. So I will now disconnect the zone program so that we could create it together. Now we don't have a problem in our component. Now here, let's assume that we have an office building, and this office building is a core surrounded by 4 cells or maybe closed offices. So here we will check this component. I want also to mention that I'm using version 0.0.64 because the versions are different. So here we have a component which is called list zone programs, and here you bring the Honeybee building programs, and then you use this arrow to check or on the type of your building. And here we have the office from the drop-down list. Then we're going to use a panel so that we can know what is inside the office. And as I have told you, we simplified our building into just a lobby, which is number 12, surrounded by closed offices, which is number 4. So we're going to use just 4 and 12. And here we need to check the number of our zones so that we could easily assign them the zone type or program. So here we need to bring list item. And we will bring this list and choose, I told you we have 10. So let's assume we want to know what is 0. So you click and choose, for example, a 5. And here you can click on this so that you can know where is. So the zone that you're going to assign. So number 5 is our lobby. We need to know also where is the other lobby in the first floor. So it's 4 and 5. So 4 and 5 are the only numbers for the lobby. So here the list contains a lot of numbers because it was a very complicated project. So I'm going to delete them. And then start by typing the new project. I told you number 4 and 5 are the lobby. So we start by, we have here the office, and we need to count because it will not show you the numbers. So the closed office is number 4. So 4, enter, 1, 2, 3. So we start by 0, I'm sorry. So it's 0, 1, 2, 3, 4. 4 is the lobby. So I need to give it 12. 4, then 5, which is 12. Then 6, 7, 8, and 9, because as I told you, we have 10 zones, but it starts by counting from 0. So enter. So no enter. Please, I will just click outside the panel. And now we have, as you can see here in the panel coming out from the list item, the items that we have chosen. So you can see that you chose closed office for zones 0, 1, 2, 3, and the lobby for 4 and 5, because as we checked here, number 4 and 5 are assigned for our lobby. So now we will hook up this into the zone program. I want also to show you that here you need to hover over the names so that you could see an explanation for each title. This actually tells you that the default of this zone programs type is open office. So here I will do this. I'm doing this. I will hook up this because we want to do the individual zoning methods instead of assigning a generic type to all the zones. Of course, it's very much simplified. You can use the other types of zones, but in a complicated project, you can find that you have other types of zones. So here I will hook up the zone programs into here. And as you can see, we don't have errors now. I want also to mention something which is very important regarding the elements of the building. In this, after you perform this intersect masses, and after you we transfer the masses into the B-reps into Honeybee thermal zones, it's called Honeybee masses to zones. It takes the ordinary B-reps, boxes, whatever components inside Grasshopper and transform them into Honeybee thermal zones. This component, another component, is called Honeybee decompose based on type. Honeybee decompose based on type, will disconnect it from here so that you can see how it works. I will also disconnect this. So now we will take it and hook up the Honeybee zones into Honeybee zones. So you can check your zones if they are correct or not. Maybe you can use, for example, let's use red color, and I might return in this again so that you can see the building outlines. This is called B-rep wireframe. You can bring it in your canvas and use the pipe and adjust the radius of the pipe so that you can see an illustration for the outline of your form. And here I will remove this one. Also, I will preview off this. Here you can check that all your elements are read in a good way. So here are the walls, which are the external walls. So here we have the interior walls. So there is a problem that the interior walls are not read, and all the walls are considered as external walls. And here comes the component that solves this problem, which is called solve adjacencies. You need to hook up the honeybee zones into the honeybee zones, and then true to find adjacencies. And here I will hook up the honeybee zones after the solve adjacencies. Now you can see that the adjacencies are solved. Here are the external walls, and this are the internal walls. So again, I will show these internal walls by hooking up the internal walls instead. And now the internal walls are shown. So let's hook up the windows. The windows are not shown. Why? Because we haven't assigned the windows yet. So the windows are assigned here. We have this component called honeybee glazing based on ratio. And this component, we assign the honeybee windows. And actually we have another component which is called honeybee glazing parameters list. And we hook up the glazing parameter list here in the glazing ratio. And we turn this into true if you want to run it. So here, breakup windows, if you make this true, you will have the windows breaked in different windows instead of having just one window for each zone. So here you can turn it into false again. And we have here, we can choose the window height. And the default is, as you can see here, the default is set to 2 meters. And here we have the sill height, and its default is also set to 0.8 meters. And we have there is other options. We have the EP constructions, and we also have brought the EB construction from the materials, which I will show you now how to do it. So now we have the windows. We can actually change any of these parameters. For example, if you want the sill height to be 1 meter, you can use 1 and hook it up the sill height. And this will change the default number assigned by Honeybee. Here we have fixed the window to wall ratio, but what if we wanted to create different parameters or different values for the window to wall ratio in the different orientations? So we can make the list instead contains 0.3, 0.5, and 0.7, for example, and okay. Of course, you can make different dynamic parameters for each of the facades. Here I will list item. I'll choose this list and hook up the items in all facades in order to minimize the calculation time, not have a lot of values for the dynamic parameters. And so here we have this list, and we can use so as to hook it up in Octopus. So I will here choose to have edit, right click and edit. And here the maximum number is going to be 2. So we can change it from 0.3, 0.5, and 0.7, and so on. Another important thing I want to tell you about is in the Honeybee masses to zones, which is conditioned. It means that do you want your building to be naturally ventilated or it has an AC? So the default is set to be that it has an AC. So as you can see here, if no value is connected here, all zones will be conditioned with an ideal air loads system. So after this, we will use again the Honeybee solve adjacencies after assigning the windows. And again, I will check by Honeybee decompose by. And now you can see that the type of the Windows type is now clear, and the building is read well. Now here also you can check for the floors and for the ground floors, because this is a ground floor, the one in the bottom. And now we are sure that this model is read in a good way.